The making of electronic chips. ASML estimated that in 2020, 932 billion chips were produced and sold globally. That number climbed to an unprecedented 1.15 trillion chips shipped worldwide in 2021 as companies raised production rate to meet a worldwide microchip shortage caused by supply chain issues and the impact of COVID-19 coronavirus. Source: Power and Beyond. Taiwan Semiconductor Manufacturing Company is the world's largest contract chip manufacturer, and it has the bulk of its chip production in Taiwan. Source: Yahoo Finance. According to The Economist, no industry matters more to Taiwan than chip making. They are the chips that power everything from mobile phones to electric cars, and they make up 15% of Taiwan's GDP. Taiwan produces over 60% of the world's semiconductors and over 90% of most advanced ones. According to ASML, the microchip manufacturing process involves hundreds of steps and can take up to 4 months from design to mass production. The world's largest dedicated independent pure-play semiconductor foundry is located in the Hsinchu Science Park in Hsinchu, Taiwan. Semiconductors are performing amazing despite the acute chip shortage that began in the first half of 2020. But in 2023, the shortage is recovering. In 2023, the output has reached about 85.6 million units, and by the end of 2028, it will be 94 million units. Source: Enterprise Apps Today. Silicon is the material of choice in the chip industry. Unlike the metals normally used to conduct electrical current, silicon is a semiconductor, meaning that its conductive properties can be increased by mixing it with other materials such as phosphorus or boron. Source: ASML. China is the main source country for many required critical minerals, including rare earth elements. China accounts for 79% of global raw silicon and 70% of global silicon production. Welcome to Real World Sci-Communications. Kindly like this video, make some comments, subscribe, share, and hit the notification bell. And to our returning subscribers, thank you so much for being partners in progress. Electronic chips, also known as integrated circuits, ICs, are complex devices that are crucial components in various electronic devices, such as computers, smartphones, and televisions. The process of manufacturing electronic chips involves several intricate steps that require precision and advanced technology. Now let's look at how electronic chips are made. Number 1. Designing the chip. The first step in chip manufacturing is the design phase. Engineers and designers use computer-aided design, CAD software, to create a blueprint of the chip's layout and functionality. This includes determining the arrangement of transistors, interconnections, and other components on the chip. Number 2. Wafer fabrication. Once the chip design is complete, the next step is wafer fabrication. Silicon wafers, typically made from high-purity single crystal silicon, serve as the base material for chip production. The fabrication process begins by cleaning the silicon wafer to remove any impurity. The silicon wafers are used as the base for electronic chips because silicon is a semiconductor material that can both insulate and conduct electricity. The silicon wafer is created by melting raw silicon in a crucible and then slowly pulling a single crystal silicon ingot out from it. This ingot is then sliced into thin wafers. Number 3. Photolithography. The silicon wafer undergoes a process called photolithography, which involves applying a photosensitive material called photoresist onto the wafer surface. A mask containing the desired circuit pattern is then placed over the wafer, and ultraviolet light is used to expose specific areas of the photoresist. Number 4. Etching. After exposure to UV light, the wafer is subjected to a chemical etching process. This selectively removes either the exposed or unexposed areas of the photoresist. Depending on whether positive or negative photoresist is used, the etching process transfers circuit pattern onto the silicon surface. Number 5. Doping. Doping is a crucial step in chip manufacturing that involves introducing impurities into specific regions of the silicon wafer to modify its electrical properties. This is achieved by depositing dopant material such as boron or phosphorus onto the wafer surface and then heating it to allow the dopant to diffuse into the silicon. Number 6. Deposition. Various layers of materials such as metals and insulators are deposited onto the wafer surface using techniques like chemical vapor deposition, CVD, or physical vapor deposition, PVD. These layers serve as interconnect, conductors, and insulators between different components of the chip. Number 7. Second lithography and etching. Multiple iterations of lithography and etching are performed to create the different layers and patterns required for the chip's functionality. Number 8. Ion implantation. This process involves bombarding the wafer with ions to change the type and amount of dopant in certain regions, which alters the electrical properties of these regions. Number 9. Metallization. In this step, metal layers are added to connect the components of the chip together. Copper or aluminium is often used for this purpose. There is a term called annealing. After each layer is deposited, annealing is performed to remove any defect introduced during the deposition process. Annealing involves heating the wafer at high temperatures to repair crystal lattice damage caused by doping or deposition. Number 10. Testing and packaging. Once all the necessary layers and patterns are created, the wafer undergoes extensive testing to ensure its functionality. Defective chips are discarded, while functional ones move on to the packaging stage. During packaging, individual chips are separated from the wafer, mounted on the substrate, and encapsulated in a protective casing. Number 11. Final testing. After packaging, each chip undergoes final testing to verify its performance and functionality. This includes electrical testing to ensure that all components on the chip are working correctly. Number 12. Quality control. Throughout the entire manufacturing process, rigorous quality control measures are implemented to ensure that each chip meets specific standards and specifications. This involves various inspections, measurements, and statistical analysis techniques. It is important to note that this simplified overview of the chip manufacturing process, which can vary depending on factors such as chip complexity, technology node, and manufacturing facility capabilities. The actual process involves numerous additional steps and sub-processes to achieve the desired chip functionality and performance. Thank you for listening, and kindly drop a comment below in the comment section. Let's know what you think about how chips are made.